Hey guys, it's Miss Johnson and I'm here to bring us Unit 1 Notes 5 notes video today. Today we are talking about graphing inequalities. So that is our learning target today. I can graph inequalities. The last notes that we did, Notes 4, was all about graphing equations that were given to us in slope-intercept form, point-slope form, or standard form. And today we're going to look at how we, instead of graph those equations, turn those things into inequalities and graph those. So our review up at the top, we're just going to start with reviewing some equation graphing and think back to notes 4. This was before your last quiz. So we would look at an equation like this, y equals negative 3x plus 5, and y is already solved by itself, so I don't need to do anything to change the equation. I look at the y-intercept, which is positive 5, come up 5 spots, and then I also take a look at the slope, which is negative 3, which means I go down 1, 2, 3, and then over 1. And I can keep doing that a couple times. 1, 2, 3 over 1, 1, 2, 3 over 1. I do that enough times so that I can make a nice line through those. And I want to span the whole coordinate plane. That's especially going to be important today when I graph inequalities. So I'm going to make sure my line spans the entire coordinate plane and that I put arrows on the end showing that it's going to continue. In number 2, I don't have y by itself, so I need to start with that. I need to add the x to both sides so that that moves over. Then I have 3y is equal to x plus 6. Remember that x and 6 are not like terms because one has a variable and one does not, so I cannot put them together. So then when I divide by 3 to get that y by itself, this is a 1 in front of the x, so I really have 1/3 x plus 6 divided by 3, which is 2. So that's the equation that I'm actually going to graph there, and then I put that on my coordinate plane. So my y-intercept is positive 2, and then my slope is positive 1/3, so up 1 and over 1, 2, 3. Up 1 over 1, 2, 3. Remember that you can also go backwards, down 1 and left 1, 2, 3, and that'll keep you on the same line. Down 1 and left 1, 2, 3. And there's the line that goes through those points. Now in number 3, normally we're looking for the y variable to be by itself, but 3 doesn't actually have a y variable. There is no y variable. So my only equation in number 3 is just x equals 5. So I need to ask myself, where does x equal 5? Well, x equals 5 right here. So then you also have to wonder, is this going to be a horizontal line like that? Or is this going to be a vertical line like that? Well, if you want x equaling 5, you can't draw a horizontal line like this because down here x equals negative 8. Here x equals negative 4. Here x equals 0. That doesn't fit with our equation. Our equation is x equals 5. So we want all the places where x is equal to 5. Up here, y is 8, but x is still 5. Here, y is 5, but x is still 5. Down here, y is negative 6, but x is still 5. This is a vertical line going through that x equals 5. That's what equations look like when there's no y variable. Okay, so that's just a little note to yourself. Now let's talk about the steps to graphing inequalities with 2 variables. So just a reminder from when we talked about inequalities a few days ago back in about notes 2, I want to say. These are what our inequality symbols mean. We've got the less than, the greater than, the less than or equal to, and greater than or equal to. Those lines underneath mean that we're also equal to those points. So now let's talk about our steps. In number 4, we have the inequality y is less than or equal to 2x plus 3. Now, here's your first step for those steps there. The first thing that I want to make sure I do is to put the equation in slope-intercept form. Okay, so that means I want the equation in y equals mx plus b, if you need to remind yourself. Or in other words, that means I want to solve for y. Now, if I look at number 4 is already solved for y, so I'm already done with step 1. Yay. Then the next thing that I'm going to do is I'm going to decide what kind of line I want to make. Now I can make a dotted line if I'm looking at less than or greater than, strictly less than or strictly greater than. Or I make a solid line if I'm looking at less than or equal to or greater than or equal to. So basically if you've got that line underneath like this, there's that line underneath, then you're going to have a solid line on your coordinate plane. So this one is going to be solid um, because I have that less than or equal to. Then the next thing I need to do is I also need to decide where I want to shade. So I'm going to decide if I want to shade up from the line or if I'm going to shade down from the line. Now if I think about greater than or equal to, those are points that are going to be above the line. And we'll talk about what above the line looks like. Less than or equal to are points that are going to be below or down from the line. Now if it's hard for you to think about the up and down and all that stuff, you can always just pick a point. If you pick a point, plug it into the inequality and decide if it's true or not. If it's true, shade wherever that point is. If it's not true, shade the other side of the line from where that point is. So you can always do a test point if that would make you feel better. Now I'm looking at less than or equal to, so I know I'm going to shade down in this case. And then my last step is going to be to actually put it on the graph. So here we go. This inequality, we graph it the same way, has a y-intercept of positive 3. So we graph it the same way as equations. Start with the y-intercept of positive 3. Then I'm going to look at the slope. So the slope is positive 2. That means I go up 2 over 1. Up 2 over 1. Remember that you can also go down 2 and left 1. Down 2 and back 1. I'm going to do that a few times just so that I have a lot of points to make this inequality line. All right, so there's my line. Now I have to decide how I connect it. This is a solid line, so I'm going to draw a solid line just like I would if it were an equation. And then the next thing I have to decide is where to shade down. Now imagine you're a person climbing this mountain. Okay, here you are. Doot, doot, doot. You're smiling. Hi. If you're going to go down underneath in the mountain, you're going below the mountain, it's kind of like you're crawling into a little hole. So you're coming down below where the mountain is, which means I'm shading on this side of the line. That's kind of how I think of it. Okay. We're going to do a bunch more examples like this. So let's take a look at number 5. In number 5, I have y is greater than x minus 6. Okay, my first step would be to put this in slope-intercept form. Well, check. Y is already by itself, so I'm good. My next step is to decide the line. This is a strictly greater than, which means I'm going to use a dotted, or some people call it a dashed line. Dotted or dashed, either one is fine. And then I also need to decide the shading. And since it's greater than, that means I want to be above the line, so I'm going to shade up. Okay, so those are the decisions that I have to make. Now I like to make those decisions before I actually graph the line because in this case, I want a dotted line and it's so automatic for us to just go zoop and connect all of the points together. And then we've got a solid line, and if you're doing it in pen, then you can't erase and it's just a mess. So I always like to make those decisions before I do the line so that it reminds me, oh, I need dotted, don't connect all of them. So now let's actually make the line. So my y-intercept is down at negative 6, and my slope is just a positive 1. So I'm up 1 over 1, up 1 over 1, up 1 over 1, and so on. All right, so I want a dotted line, dashed, whatever you want to call it. Either way, they're not connected all the way. Okay, so that just symbolizes that the points on the line are not actually included. The line is just really more of a boundary at this point. Okay, then I want to shade up. So again, if you're a little person climbing on the mountain, here you are, let's say you jump up in the air. Where do you go if you jump up in the air? I come up into this region. So I want to stay above this line. Okay, so there's my shading. Let's flip over the back and try number 6. So in number 6, I have y is greater than or equal to negative 4x plus 2. Again, my equation's already solved for y, so I'm done with the first step. That's good. Then I want to make my choices. I have greater than or equal to, which means I want a solid line. And greater than means I'm shading up. So now let's put it on the coordinate plane. My y-intercept is negative 2, so I'm going to come down 2. I'm sorry, hello. My y-intercept is positive 2, not negative 2. There we go. Up 2, sorry, my fault. Now my slope is negative 4, so I am going to come down for the slope. So down 1, down 2, down 3, down 4, over 1. Let's do that again. 1, 2, 3, 4, 1. You might be off your coordinate plane a little bit, but that's okay. Don't forget that you can go up and back too. 1, 2, 3, 4, and back 1. And there's my line. So I want this to be solid. I'm going to connect the points. I'm including the points on the line. Sorry, I did not draw that very well through my points, but you get the picture. And I make an arrow there, and then I want to shade up. So if you're a little person on this very steep mountain and you jump up in the air, you're in this region over here. Okay, now let's talk about number 7. Again, I'm in slope-intercept form. Yay. So now I look for the line and I graph it from there. So y is greater than 1/2 x minus 2. So my y-intercept is a negative 2, and it is actually negative 2 this time. I'll do it right this time. Oh, I forgot to make my choices. So when I make my choices, here's my inequality symbol. I know that I want a dotted line because I am not including the values. I don't have that line underneath. And I know that I want to shade up again. Okay, so um, negative 2 for the y-intercept, positive 1/2 for the slope. So that means up 1 over 2, up 1 over 2, or down 1 and back 2, down 1 and back 2. Dotted line, looks like that. And shading above, this is just more like a hill instead of a mountain this time, but you're still climbing on the hill. Jump up in the air. There you are, up in this region above. Again, don't forget that you can test a point. So if you want, say like 0, 0, plug in 0, 0 in for x and y and see if it's true or not. If it makes this inequality symbol true, then that's where you shade. If it made this inequality, if it was false, then you would shade down below. Let's take a look at number 8. Ooh, now we're looking at lines that are in standard form. Uh-oh. Well, that's okay, because we've already practiced this, so we know what to do. The first thing that we want to do is we want to get this y value by itself, or y variable by itself. So it means I'm going to subtract the 3x. So I have negative 2y is greater than negative 3x minus 6. And then I need to divide by negative 2. Now when I divide by negative 2, don't forget that in inequalities, that means you need to flip your symbol. So this is now going to become less than or equal to. This is why we do that first, because if you would have made all those choices first, you would have said, oh, I need to shade up. But no, we're actually flipping the symbol, so you really need to shade down. So solve for y first, then make your choices. Over here, let's simplify this right-hand side. Negative 3 divided by negative 2 actually gives me a positive 3 over 2. And then negative 6 divided by negative 2 is positive 3. So there is my inequality that I'm going to graph. Y-intercept is positive 3. Oh, and let's make our choices. This is a dotted line. This is shading down. So y-intercept of positive 3, slope of 3/2. That's up 1, 2, 3 over 1, 2. Up 1, 2, 3. I'm off the coordinate plane a little bit, but that's okay. Or down 1, 2, 3, back 1, 2. 1, 2, 3, back 1, 2. So there's my line. It's dotted or dashed, if you want to call it that. And then I want to shade down. So if you're climbing up the mountain and you go down into a hole, you're down here. So there's my shading. Let's try number 9. I have 5x plus 2y is less than or equal to 10. So, ooh, sorry, just 5x plus y is less than or equal to 10. No, that should be a 2. Your page has a 2. Sorry, should have a 2 there. So the first thing I need to do is get that y by itself. So I'm going to subtract 5x. And I have 2y is less than or equal to negative 5x plus 10, and then divide by 2. And when I do that, I end up with y. I don't need to flip my sign because I'm dividing by a positive. So y is still less than or equal to negative 5 halves x plus 5. All right, so let's make our choices and draw our line. Here's the inequality I'm working with now. Sometimes there's a lot of work on the page. It helps if you circle it. I know I want a solid line. That inequality symbol tells me that, less than or equal to. And I want to shade down because it is less than. So positive 5 for my y-intercept, down 5 and right 2 for my slope, down 5 and right 2 for my slope. Kind of hard to get some more points on you here without going off the coordinate plane, but that's okay. So solid line. Again, you can use a straight edge, the edge of your folder, the edge of your calculator, whatever, to help you. If you have a ruler, that'd be great. And then I want to shade down. So if I'm on the mountain and I go down below it, that means I'm here. And there we are. To the left. So now I need to take these lines and solve for y in number 10. They're not necessarily in standard form, but they don't have y by themselves. So that's what I'm going to do. Y plus 3x is greater than or equal to negative 6. I first need to get rid of that 3x term. So then I have y is greater than or equal to negative 3x minus 6. All right, so y is alone. I know that my symbol tells me I'm going to have a solid line, and I'm going to shade up because it's greater than or equal to. So now let's put that on the coordinate plane. Negative 6 is way down at the very bottom of your coordinate plane. So it's going to be hard to have a negative 3 slope because you're already going to be off your coordinate plane. So I'm going to go up 3 and back 1. I'm just going to already start counting backwards. So up 3 and back 1. Up 3 and left 1. Up 3 and left 1. 1, 2, 3, left 1. And this is a solid line. So I'm connecting all of them. And I'm shading up. So up is up here. All right, very last example. Negative 2y is less than 4x minus 10. I need to get y by itself, which means I need to divide by negative 2. Inequalities, so whenever I divide by a negative 2, this gets flipped to greater than, or it gets flipped to the other direction. So I have y is greater than negative 2x plus 5. 4 divided by negative 2 is negative 2. Negative 10 divided by negative 2 is positive 5. So there's my inequality that I'm working with. I want to have a dotted line this time, and I want to shade up. So positive 5 y-intercept, and then down 2, right 1, down 2, right 1, and do that a few times so you can make a nice line. All right, dotted line, and shade up would be shade this direction. All right, this concludes our notes video for notes 5 on graphing inequalities. Don't forget to check off your notes sheet with Ms. Johnson, and thanks for listening. Have a great day.